Hi, Ryder. How are you?
Good.
Good. Tonight, I want to interview you for calculus problems. Do you know how to find the limit of this function? So when I go to infinity, can you find the limit of this function, x squared over e power x? Can you show me how you can solve this problem? Or do you have any idea when you see this problem?
Um, I think we can use the um, L'Hopital rule. Uh,
Yeah, can you show me how to do that?
so you plug in, um, you plug in infinity
Mm,
for each, or do the derivative for the bottom and the top.
mm,
Um, that should equal infinity over infinity.
mm.
So then you can use L'Hopital's rule.
Okay. Yeah, when you plug in infinity, then get infinity over infinity, then you think you can use L'Hopital's rule, right? So
Yeah.
then, yeah, how you can use it? Can you show me? Uh,
Now you do the derivative of the top over
okay,
derivative of the bottom.
okay,
And then here, I think you plug in infinity again.
okay,
Infinity. And you check if it equals infinity over infinity. If
right,
it does, then you have to do it again. So
okay,
you do the derivative of that again, of this now, which I think is 2 over e of x.
mm-hmm,
So then it's um, to plug in infinity 2 over u infinity, that equals 0.
okay. Then you get the limit of this function will equals what?
0.
You got this one zero. Yeah, the your roughly your idea definitely is very good. I think what you just need to pay attention here for your writings, like here, you when you plug in infinity there, infinity over infinity, then you cannot write that equals 2 over e power x because e power x, this is a function, right? Infinity over infinity, that's undefined. So if I write, let me show you. If I solve this problem, I'll do this way. Yeah, first, you can check if this one belong to infinity over infinity. Another one, it's 0 over 0. This, if it's belong to these two forms, that should be used L'Hopital's rule. So then you can write this one that's equals limit of this function. Then you take the derivative of x squared, you get 2x. Then derivative of e power x, you get ex. Now you do this in your mind. Say when you plug x equal infinity here, you will get infinity over infinity again. So that means you need to use L'Hopital's rule one more time. So then you write this one equals limit of this function, 2x derivative equals 2, then e power x derivative that's equals e power x. Now you just think when x go to infinity, this is a 2 over infinity. This limit definitely will equal 0 because 2 divided by a bigger and bigger number, definitely that limit will be 0. I think this is a correct way to write this solution. Another problem, right? Do you have idea to calculate this limit? Like say in 4x, okay, divided by tangent 7x when x approaching to 0. Do you have any idea to solve this problem?
Do you just use L'Hopital's rule again?
Okay. So then first tell me why you need to use L'Hopital's rule.
Let me see.
If you plug x equals 0 to this to the numerator and denominator, what is ratio you have here?
0 over 0.
Yeah, that's 0 over 0. Remember, I told you the two cases. If you get a 0 over 0 or infinity over infinity, you have to use L'Hopital's rule. Another form like 0 power infinity or like a infinity power 0, this kind of problem usually you also need to use L'Hopital's rule, but before that you need to use log or use e function, convert that to like 0 over 0 or infinity over infinity form. So then, good. Now, can you show me how you solve this problem? Yeah, follow, say what I write here. If you write this, you need to write that clearly. If you use equal sign, you have to write their limit are equal. Okay, you need to add the limit.
Okay.
And also like what is that x will approaching to? Can you write on my screen, show how you solve this problem?
So when you plug in 0 to this equation, you get 0.
You do in your mind, right? You already, when you plug in x equals 0, you got a 0 over 0. Yeah, that means you need to use L'Hopital's rule. But now, yeah, you need to take the derivative of the numerator and denominator. Okay, good. What is the tangent, derivative of tangent?
It's secant squared.
Secant square, yes, perfect.
Then
Yeah, now you use chain rule, good. Now, continue from here. Yeah, this step is perfect. You write this one's very good. Now continue from here.
Yeah, so you plug in 0 again, you get 1 times 4 on the numerator,
Okay,
then plug
go.
in 0. Secant is 1 over cosine, right?
Yeah, yes.
So you would get 1 over 1 square, which is just 1.
Mm-hmm.
So this would equal 4 over 7.
Perfect. Yes, very good. Yeah. Say after you calculate the derivative of numerator and denominator, actually the you know that singularity is gone. Then when you plug x equals 0 to the numerator and denominator, you can say the numerator that's 1 times 4. The denominator secant 7x when x go to 0, this also equals 1. So that's 4 over 7. So that's perfect.
Yeah.
Okay, now last example. Okay, let me give you another example. Can you do? Let's move this one a little bit up. Can you calculate limit of this function? 1 plus 1 over x, then power x. Then when x go to infinity. So first, after you see this problem, what do you think?
Can you just plug in infinity?
When you plug infinity, what do you get?
Infinity.
Oh,
sorry.
why infinity?
One. You get one.
Huh? Can you show me if you plug in infinity, what do you get?
Um, 1 plus 1 over infinity,
Hmm.
and then power infinity.
Hmm.
Um,
So this one, what do you get? Simplify this, what do you get?
this would just, or this would just turn into 0.
Yes.
So then you need 1 power infinity,
Yes.
and then 1 power of anything is 1, right?
So then you think this limit is 1?
I think so.
No, that's not right. Remember, this is a very famous, this is one of the famous limit. Okay? This is a one of them. Another one is when x approaching 0, sin x over x. Do you remember what's the limit for this one?
1.
Why? Why this one's 1?
I think we learned this in class. You just, like, they told us.
But this one, think that when you plug in x equals 0 to the numerator and denominator, what do you get?
1 over 0.
1
Sorry,
over 0?
0 over 0.
0 over 0. So that means you can use L'Hopital's rule. Can you use L'Hopital's rule to solve this one? Yeah, then continue. Very good. Then continue. Yeah, see, this limit equals 1. This is one of the famous limit. A lot of calculation of limit you can convert to this one. This one, that's another one. Okay. So you already get this one's 1 power infinity. That's an undefined. So for this case, you also can use L'Hopital's rule. You need to consider use L'Hopital's rule. But how you can use L'Hopital's rule here? That's a question. You know, you already get this one's 1 power infinity. That's will be a undefined. So now let's think. First, this function, you can write this one like 1 plus x over x, then power x, right? Let's assign this function like fx. Then to find the limit of this function fx, we can take log ln both side, right? We can take ln both side. So then you can say right side will change to what?
The x.
Right side, this x will go to the front, right? Can you write this? What do you get it? Right. Then you can also write this one as x times log 1 plus x minus log x, right? For the log function, the division that's actually equals minus. Let me write this one here. Let's make this one more clear. So we can write this one as ln 1 plus x minus ln x, right? So then times x, we can write this one, it's 1 over x. Is this one equal this?
Yeah.
Why?
Because you can make it like turn it into a fraction and put it in the denominator.
Correct. Now remember, x go to infinity, right?
Yeah.
So if you plug in infinity to the numerator and denominator, what do you get it here?
0 over 0.
Right. So that means you still can use L'Hopital's rule, right?
Yeah.
So then can you show me how you use L'Hopital's rule to this function, to this one?
What's the derivative for natural?
Well, natural log, that's equal to 1 over, if you derivative log natural log x, this one will equals 1 over x.
Okay.
Yeah, you use this formula. Show me if you derivative the numerator and denominator, what do you get here?
You would get
Okay.
1 over 1 plus x minus 1 over x
Correct.
over
This one, you can consider this one as x power -1, right? How you derivative this polynomial function? Yes, perfect. Now simplify this. This one, after you simplify, what do you got here? You merge these two fractions together, then can you merge these two fractions together? Yeah, let me take this part away. Okay, good. Then you continue simplify.
you cancel these out, right?
No, you cannot cancel. First, you need to expand the numerator, then you cannot just cancel like that way. If you do that way, that's totally wrong.
Okay.
be careful. This negative sign need to distribute to all the terms inside of the parentheses. No. This one, x times parentheses, this one you don't need to expand it. You just write x times parentheses x plus 1. Yeah, then you continue. Then think divided by negative x power negative 2, that's equals negative 1 over x squared, right?
Yeah.
Right, that's like negative 1 over x squared. So negative and negative cancel out, right? Then divide a fraction. You need to change to multiply the reciprocal of the fraction. So then continue right here. Times x squared over 1, right? Then continue. You can cancel out 1x from the numerator and denominator, right? Cancel out 1x.
Yeah.
Then what do you get it? X over x plus 1. You can say here, yeah, very good. You got this one, that's perfect, right? This one's good, this one's right. But it makes this one longer. Now, you know, when x go to infinity, what is this? What is this form?
Infinity over infinity.
Yes, so that means you still can use L'Hopital's rule.
So the derivative would be 1 over 1 plus, oh no, sorry. It's 1 over 1.
Yeah, so that's limit of this function will equals 1 when x go to infinity, right? So very good. This tell you the limit of this function equals 1, right?
Yeah.
But then this is not the original function we are trying to calculate it. This one is the function we already take the log. It's a limit of log fx, right? We get the limit of this function when x go to infinity. We get this one now equals 1, right?
Yeah.
We find the limit of this function equals 1. Then can you find the limit of original function fx from here?
Would that mean this equals just e?
Fx, write this, you don't write like that. You need to write, yeah, your idea, that's correct. Yeah, fx, the limit equals e, right? So then say, what is fx? The fx is the function that it's this function, right? Remember, I assign this function as fx.
Yeah.
Right? So therefore, you get the limit of this function that's equals what? E, right? So this is an idea to prove the limit of this famous function, famous limit there equals E is not 1. After you know this, then this famous limit will help you solve a lot of very complicated limit problems. Okay, last one, okay? Let me give you an example. If you can finish this one, then we will stop here, okay? Can Can you find limit of this function? Log, when x go to infinity, 1 plus 1 over x, then power 2x. What is the limit for this function? Can you find this one?
Is it 2e?
Why 2e? You need to show me how you get it.
If you log this function 2x so that you know that this equals e.
Double think that's not right. So yeah, I like you can still if you don't can convert this one to like this form, you can do this way. You can start like a set like fx equals 1 plus 1 over x, then power 2x, right? You still can do this. Then you do both sides, take log, take ln, then get the right side will equals 2x times log. Then remember, we can write this one 1 plus x, then minus log x, right? You can also continue, right? This one's log 1 plus x minus log x, then divided by 1 over x. But then you keep that 2 in the front because that's constant. After you get your limit of this function, then you just times 2. Remember, we already know this, the limit of this function when x go to infinity equals what? Right there.
0 over 0.
0, 0. Later, you find the limit of this function equals what? After you use L'Hopital's rule.
When you do L'Hopital's rule on this.
Yeah, to this. You already get this, right? You know, when we assign fx equals 1 plus 1 over x, then power x, then we get this, then we use the L'Hopital's rule twice. Then we prove this limit of this function equals 1, remember?
Yeah.
After we get this 1, then we go back to the original function fx, then get this original function, the limit is e, right? Because e power 1, that's equals e, right?
Yeah.
So then here, this one same. So limit of this function is still 1, right? Then you times 2, you get the limit of this this function log fx. If fx equals this, then what is the limit for this function? Tell me, what is the limit for this function?
Which function?
Ln fx. If fx now equals 1 plus 1 over x power 2x. You know, this one equals limit 2 times limit of that Ln function. Remember, that's this one, 1 plus 1 over x, then parentheses power x, right? That's this one. Limit of this function, you already know that's equals 1. So therefore, the limit of this function log, that's equals 2. So right? Because limit of this one, that's 1, right?
Yeah.
Now, unit time is constant too. So therefore, the limit of log fx, now this fx is this. The limit is 2, right? So then what is the limit of original function of this function?
E squared.
Yes, right. Then you got a limit of fx. When x go to infinity, that's equals e power 2. Okay? Wonderful, right? So then you can say this famous limit is so powerful. After you know this, you can use this one as basis. Then you can help you solve a lot of problems. Actually, if you already familiar this, you don't need to do this one more time. I can show you. You just need to write this function as 1 plus 1 over x power x, then power 2. Because we can convert this one like this. You can write this one as 1 plus 1 over x parentheses power x, then like this, power 2. Right? Is this one right?
Yeah.
Because based on the powers rule, this power can multiply with this power. So if you expanded this, you can write like 1 plus 1 over x parentheses power 2x. So therefore, you can take this limit inside of this function. We already get this one. You already get this one. See, that's limit is e. So then you just plug e here, then outside, that's power 2. You immediately get this one. Okay? Then I leave a homework for you, okay? Can you calculate this one? 1 plus 1 over 2x. Then parentheses power x. What is the limit of this function? Okay, this one's your homework. Okay, can you calculate this? So we can stop here. Thank you very much. Okay, bye.
Bye.